Hello, I'm Philippe, and this is AP Calculus BC 2004, number 6. Let f be the function given by f of x equals sine 5x plus pi over 4, and p of x be the third degree Taylor polynomial. For f about x equals 0, find p of x. Okay, so I set this up, 5x equals sine 5x plus pi over 4, and you may be thinking, okay, well we know what sine of 5x is going to be, or sine of x, the summation for the max series. However, this is not what you want to do. You don't want to plug in 5 here, or 5 plus pi over 4, because that's not correct. And the reason is because it's plus pi over 4. This is going to be a little more daunting to deal with when it comes to making a summation about it. We don't know what sine 5x plus something. We know what sine 5x would be, but not 5x plus. So you need to do the derivative. So 0th derivative, the first derivative, the second derivative, third derivative, so the original function onward. And just keep on plugging in x equals 0 into each of the derivatives to find the corresponding values. Again, just pay attention when you're taking derivative cosine, it's negative sign, and to pull out the 5 in your chain rule. And finally, when you take these derivatives, you'll plug in 0. I'll get square root of 2 over 2, 5 square root of 2, negative, and onward. So with these numbers, we're going to write our Taylor polynomial. Remember your 2 factorial. This is, you may forget this because they put the 2 there. It doesn't mean you have to omit the 2 factorial. You need the 2 factorial. So just remember that. And finally, also the 3 factorial. And there we go. We have p of x to the third degree, which is the third degree is here. Everything else set forward as p of x. The next part states find the coefficient of x to the 22nd, and the Taylor series f of x equals 0. Okay, so I wrote out all the terms of the coefficients, or at least the derivatives. I'll deal with the coefficients a bit later. These follow a pattern. You go by 5 to the nth power. So if we're going this, if you think of x to the 22nd as the 22nd term, it would be 5 to the 22nd power times square root of 2 over 2, because that's always constant in these problems. Remember the 22 factorial. You may forget that. Finally, the hardest part is going to be what the sign is going to be. Positive, negative, negative, or positive. But these follow a pattern. So if there's 22 terms and it follows this 4 pattern thing, you can just divide 22 by 4, and you get 5, remainder 2, so it goes by 5 sets of these things, and you can remainder 2, which is 2 steps, plus, minus, so minus is going to be what this is. Again, you just kind of look for the pattern, and divide by how many outcomes you can have to get your kind of remainder, and you'll solve for the sign. Right, next one is use the Lagrange error bound to show that f of 1/10 minus p of 1/10 is less than 1 over 100. Okay, just a quick reminder of the Lagrange error. It's the max of the derivative of the next term times x minus a of the next term to the next term power divided by the next term factorial. In this case, x equals 0, a equals 1/10, and the next term is 4, because if you remember what p of x is, it is a third degree Taylor polynomial. So the next term would be the fourth. Again, x equals 0, a is 1/10, a is this, and it will be 1/10 the fourth power. We can ignore the negative sign because it's be the fourth power, and it's an error. Probably the most tricky part is the max of the fourth derivative. If you remember what the fourth derivative is, let's go back to here. The fourth derivative would be 625 times sine 5x plus pi over 4. So the max of this is not going to be what it is at the 0th derivative, because c has to be in between 0 and 1/10, but not, it doesn't have to be 0 or 1/10. In this case, it would not be. We know that sines go, the highest point in sine is 1, the lowest point is -1. That is going to be your max to min. So the max is going to be 625. So let's plug in 625 here, because that's going to be the highest. It's not going to be 625 times square root of 2 over 2, because that's square root of 2 over 2 is less than 1, and therefore would not be the max. Again, it would be 625. That would be a drop answer. So this simplifies to 134, which is definitely less than 1 over 100. Although you can leave it in this form and just say it's less than 1 over 100, and we prove that the error bound is less than 100. Again, this is kind of set up for the error. Probably the hardest part here is finding the max of the derivative, and it's not always obvious. It's not going to be the second derivative, the fourth derivative, or the derivative evaluated at 0. Again, it's the maximum of derivatives. Just pay attention when you're doing that. Finally, the last part is let g be the function given by g of x equals integral from 0 to x of t. Write the third degree Taylor polynomial for g about x equals 0. So I wrote back the p of x. This is all we're going to need. And I'll just do a quick antiderivative. Again, antiderivatives of Taylor polynomials are very simple, because they're all polynomials. Alright, so this is going to be our derivative. And this is a definite integral, so we don't need to put a plus c. But if they just ask you for the antiderivative, you're going to need to put the plus c. Be careful about that. Again, it's a definite integral. You have 0, so it's f of x minus f of 0, capital this. So the 0 term just cancel out because you're plugging this in, and it just cancels out everything and becomes 0. But just be careful when they ask you for antiderivative. You might need a bit plus c, or you might need to insert something into the Taylor polynomial and solve for something. Anyway, that is all for this problem. If you need more practice, some great ones are 2016 number 6, 2015 number 6, or insert any year number 6. Really, if you go to any AP Calculus BC problem, and you go to the 6th problem, you're going to find a Taylor polynomial in Math Learning Series. But some good ones is 2016, 2015. 2014 is a good one. 2013 is also a good one. Anyway, thank you for watching. I hope you found this useful.